Welcome back. Alright, so last time we talked about those 4 things that could cause variation. And, number 1 was about these new combinations in meiosis. So, I'm going to call this one, it's like a new dance phase. The Meiosis Shuffle. Meiosis Shuffle. We've been doing this. It's not so much a fad anymore because it's hard to imagine that since the beginning of eukaryotic organisms that this dance has been going on. This is more than the Icky Shuffle. This is more than Gangnam Style. This is more than even the Harlem Shake. So what are we talking about here? Just remember that meiosis and fertilization in our genes. I remember we talked about there's a random. So it's a random thing, and it's different every single time. Every one of your sperm or egg cells are going to be different than the other one. And in fact, let's do a little math here. So if I had just one, change this color here. If I had one chromosome pair, one pair, how many possible choices do I have? Well, I could have the left side or the right side. So I have 2 choices for one pair, 2 to the first, and that's equal to 2. And if I had 4 chromosomes in 2 pairs, it'd be 2 to the second. We got 4. 2 to the third is 8. 2 to the, how many chromosomes do we have again? How many pairs? We have 23. Do a little math there. Take your phone, and oh, by the way, to do this, you're going to need to turn it landscape style to get this to work, because, your phone, it doesn't come in otherwise. But this, let me do the math for you, I've already done it, is 8,388,608. That's an 8 right here. 8, that's... Wait, okay, so you're telling me that we can produce 8,388,608 sperm or eggs and not have the same combination of chromosomes? That's exactly what I'm telling you. Now you combine, well, what's the chances that that one unique sperm that made you and that one unique egg that made you, they actually came together? Well, we're going to take that 8 million, we're going to square that. Wow. I had to look this up. I had to look up what you call this. This is a 70 gazillion. 70 gazillion. 368 trillion. 744 million. 177,664 different possible combinations when you combine the one sperm and the one egg. And that doesn't even count. We're not even talking about crossing over. Not even bringing it up. It's just the shuffle, the meiosis shuffle. Talk about variation. Talk about differences. Talk about changes. Amazing. So sometimes though, so let me also put in here, hey, don't forget crossing over. So again, this is all about, being able to increase the amount of variation that we have. Okay, well, sometimes, again, there's some mistakes. And so what happens when we have these critical mistakes that happen? Okay, let's talk about it. Okay, so we're going to call these, because sometimes meiosis doesn't work quite right. Okay, remember, normally we produce chromosomes or sex cells. So, meiosis produces sex cells or gametes, that have half the number of chromosomes. That's normal. Okay? Like for instance, our sperm and eggs have 23 chromosomes. Normally. There's sometimes mistakes that happen. Okay? We're going to produce 4 cells each. Okay? So sometimes we have these things called non-disjunction. And you don't really have to know that term. It just makes it easier to talk about. Non-disjunction means that the pair, we're talking about up here, this pair doesn't always separate quite right. And for instance, you might get, think of you're dealing cards out, okay, and you deal them out in pairs. You separate the pairs. Well, let's say the 2 cards were stuck together for whatever reason. They, came together. Well, that means one person is going to have an extra card, and one person is going to be short a card because the extra one didn't go to that person. It went both to one. Okay, so an example of this is called Down syndrome. And what we have in Down syndrome is a non-disjunction that happens in chromosome pair number 21. It produces what we call a trisomy of number 21. Tri meaning 3. There's 3 chromosomes because one of the chromosomes is going to come from the other parent. And there was a non-disjunction producing an extra chromosome in the other parent's gametes. So when they come together, instead of having just 2, 1 from each, you're going to have 2 from one and 1 from the other. Some other examples. And this happens in the sex chromosomes. So normally you would either have an XY for a male and an XX for a female. By the way, write this down. Easy way to remember. If you have a Y, you're a guy. If you have a Y, you're a guy. Always works. Okay? And the example I was going to mention here is when you don't. Okay, so for instance, Klinefelter syndrome, you are an XXY. That's an X. XXY. You're male because you have a Y. Okay. But there's some fertility issues, some a little bit more feminine qualities and stuff like that. Okay. And the last example is also one that happens in the sex chromosomes, and that is called Turner syndrome or Turner's syndrome. It's almost like the opposite partner, where one person, we're talking about cards, and one person would get an extra card. Well, they got an extra card. Well, this individual was short a card. And they are an X, and we call it 0 or XO because they don't have, this is really a missing, they really just have one sex chromosome, the X. So are they male or female? If you have a Y, you're a guy. They are female. Okay? They don't have a Y. Okay? Now, all of this, and I'm running out of space here, so if I could just maybe clear off this space right here. Ready? 1, 2, 3. That's so much better. So sometimes we're just going to talk about like little bits and pieces of chromosomes getting lost. So I need a different color. Keep using that same color. Get some green in here into our lives. Okay, so sometimes what if we have bits and pieces of chromosomes are lost or gained? So let's say this is normal. We have an A, we have a B, we have gene C, we have gene D. So that's our normal. Well, what could we have? We could have an addition. We have an addition or an insertion. Well, could look like that. And now we have like A, B, C, C, and D. So notice this second C, or the first C, we're not really exactly sure, they were added in. Okay, an addition or an insertion, either one. Okay, well, what about a deletion? Probably could figure this one out based on this one. Well, again, one's loss is the other, one's gain is the other's loss, I guess I would say. Get a little bit more here, here, and here. So we're going to go A, B, D. Oh, probably these two were in the same one. This loss here was a gain here. Okay, and lastly, we can have what's called a translocation. And this is really just like that process of an addition and deletion, but they happen on different chromosomes altogether. So let me show you what that looks like. So again, we have our chromosome, okay, but they're going to have an extra piece down here. And so this extra piece is going to be A, B, C, W, and D. So note that this gene right here came from a different chromosome pair. Okay? So we covered a lot. Let's just talk about it real quick and move over here where we can see. Again, we were talking about how the Meiosis Shuffle, this dance that's been going on forever, produces one of those ways of doing variation, allows changes to take place. And we talked about how, it's a shuffling, a random selection of one chromosome versus another, and crossing over. We did some math and we found that, holy God, the number of different possibilities. Just think how unique you really are. You're one of 70 gazillion possibilities if your parents could take it. And we could have 70 gazillion plus children and the same two parents and never have the same one, provided there's no twins. Okay, we start talking about some of the errors that can take place. And it all came from this non-disjunction where the pairs don't separate together. They go together. And that can produce Down syndrome, Klinefelter syndrome, Turner syndrome. And then even like bits and pieces can be gained and lost. This is more a result of, crossing over going on, mistakes in crossing over. Okay? Well, I hope that helps. Going into those other three variations soon.